Hello everyone, welcome back to the channel Code with AKJ. Today is day 24 of solving Geeks for Geeks problem of the day. Today's question is minimum jumps. The question here is given an array ARR of non-negative integers. Each array element represents the maximum length of the jumps that can be made forward from that element. This means if array of I is x, then we can jump any distance y such that y less than or equal to x. Find the minimum number of jumps to reach the end of the array starting from the first element. If an element is 0, then you cannot move through that element. And return -1 if you can't reach the end of the array. So the given here input array contains the number of steps at particular current element. So here the first jump from the first element. So here the value of the current step is 1. So we can jump from this position to one element further. So the first jump would be one step and second element value is 3. So we can jump from 3 to 3 steps forward from this particular position. It means we can jump from 3 to 5 or 3 to 8 or at max 3 to 9. So in this way we'll use the current step value and we need to jump from that position and somehow we need to reach the end of the array. If in case we cannot reach the end of the array, we need to return -1 here. So let's understand that given example through a diagram. So here I have written the array elements and the indices values. So initially, since our first element has a value, we can start jumping from this position. If in case the starting element remains 0, we cannot jump from the position and we cannot reach at the end of the array. So initially we need to check the particular condition, which would be a base case, that if a current starting element value is 0, we cannot jump from that position and reach the end of the array. So we'll return -1 there and there itself. So coming to this example, and the initial element is 1, so we can take at max 1 jump from this position. So we'll reach at index 1 here, and this index value has element 3, which means we can jump from this position at max 3 positions forward. So here from here we can either jump from 3 to 5 or 3 to 8 or 3 to 9. So in this way at max 3 jumps can be possible. So we need to select jump which will help us to reach at the end of the array. So in the same way, if we consider 5, then we can jump from this position 5 steps forward. So from 5 we can jump to 8, from 5 we can jump to 9, and so on and so forth. So this is the basic idea of the problem statement, and we need to find a solution to reach the end of the array starting from the initial element. So the brute force approach here would be to explore each and every path and check which particular path will help us to lead the end of the array in minimum number of jumps. So this would be the brute force, and since we need to explore all possible paths, we can only think of an algorithm called recursion. So we'll use recursion here, which will help us to explore all possible paths, and we'll find the path which gives us a minimum number of jumps to reach the end of the array. So before moving to the code, let me just explain the possible path we can explore from each and every position. So coming to the value 1, from 1 we can move to 3, and from 3 we can move to 5, 8 or 9. And if we consider 3 to 5, then 5 can move forward to 8, 9, 2, 6, 7. It can reach at max 7. If we consider 3 to 8, then the possible paths would be 8 to 9, 8 to 2, and finally from 8 we can reach the end of the array, that is 9. And if we consider the path from 3 to 9, so from 9 we can also reach the end of the array. So in this way there are two possible paths which will make us lead to the end of the array, that is 1 to 3, 3 to 8, and 8 to 9, which is the end of the array. And the same way 1 to 3, 3 to 9, and 9 to 9. So here there are two possible paths and the number of jumps would be 3. So we'll return 3 in this case, which would be our answer for this problem statement. So let's try to code this approach and we'll see whether it gets accepted or not. So this is the code for the brute force approach we have discussed through the diagram, exploring all the possible jumps from the current position. So initially I have taken the size of an array in the form of variable n, and I've called the function solve recursive. By exploring all these possible paths, if we somehow reach beyond the end of the array, we'll return 0 here. And if there would be another edge case that if the current position value is 0, we cannot jump from that position and we will not reach the end of the array. So hence we return the int max value here since we cannot jump further. And finally I have taken a variable which will be int max initially, and I have used a for loop which will explore all the possible jumps from that position. I have called the recursive function from that position, and if it returns a value which is valid, then we'll recursively call for next subarray. We'll take the minimum value of both the calls. So in this way, we'll update the jump value by exploring all the possible jumps, and finally we'll return that jump value. So let's compile and run this code and let's see whether it gets accepted or not. So here the time complexity would be O of 2 power n, as we are using recursion and it generally explores all the paths and it creates a recursive tree, making it 2 power n as a time complexity. And here space complexity would be O of 1, neglecting the stack space. So let's compile and run. Let's submit. As you can see, it gives time limit exceeded as it calculates a particular state again and again. So if we try to optimize this, we can optimize a little bit by using memoization here. So let's memoize this code and again compile and run and submit whether it gets accepted or not. So this is the memoized code. I've used the vector of dp as this particular index is being changing after each and every call. So I've taken a single dp, I've stored the value -1 initially, I've stored the values of a state, and it is being updated after each and every call. So let's compile and run this and check whether it gets accepted. Let's submit. As you can see, it optimized a little bit. It passed few more test cases, but it still gives time limit exceeded. So we need to use tabulation method, but initially here the time complexity of this code would be O of n square. We can optimize this code a little bit further by using tabulation, but still the time complexity remains same and it will give time limit exceeded because size of the array could be larger in this case. So we need to use some other algorithm. So I have explained this here. So if we use recursion, the time complexity would be O of 2 power n. If we use memoization in recursive approach, it still gives TLE as the time complexity would be O of n square. And tabulation method also gives TLE, but as the time complexity remains same and it will fail for larger inputs. So the optimized approach here would be to use a greedy algorithm where we need to calculate the steps parallelly by moving the pointers from one end to last end, and we need to solve this solution in O of n time complexity. So this is the optimized approach. Let me explain through this example. We'll maintain 3 pointers: jump, position and destination. Jump tracks the number of jumps made and destination tracks the farthest index reachable with the current number of jumps, and position tracks the farthest index that can be reached with the next jump. So here we'll iterate over this array and updating the destination value to the maximum reachable point from the current position I, and if position at any point becomes equal to the index I, then it means we need to take a new jump, and this algorithm then updates position to the destination value and increments the jump counter. So in this way, by using 3 pointers, we'll update the position value, destination value and jump value, and finally we'll return the jump value. If position is greater than or equal to the last index, it means we can reach the end with the computed number of jumps, and we'll return the jump value from here. So if not, we'll return -1, indicating that reaching the end of the array is not possible with the given jumps. So this would be the algorithm, and the time complexity of this would be O of n, and space complexity would be O of 1. So let's try run with this example, and we'll later on move on to the code. So initially the I would be at 0. We'll check whether this particular value is 0 or not. Since it's not 0, we'll move on with the next steps. We'll update the destination value, which tracks the farthest index that can be reached with the jump. So it would be the array's value and the index value, and we'll update the destination value by taking the max of previous value and the current value. Here it would be 1, and we'll check the position value is equals to the index value or not. If it equals, it means we need to make a new jump to proceed further. So since it's equal, we'll update the position value with the destination value, and we'll increment the jump here. Next, when I becomes 1 and we'll reach the index 1 with the value 3, we'll update the destination value, which would be max of previous value, that is 1, and the current destination, which would be 3 plus 1, which is totally 4. So it means from here we can at max reach the index 4 here, which would be 9. And we'll check whether the position value is equal to the index value. Here in this case it would be yes, they are equal. So we'll update the position value with the destination value 4, and we'll increment the jump here. Again, we'll increment the I value, and we'll check all these conditions. Here in this case it would be 7, and they both are not equal, position and index I. And here they are not equal since the value is level. And at the index 4, the maximum destination it can reach from index 4 would be 13, and here the position value becomes equals to index I. So in this case they both are equal, so we'll update the position value with the destination value, and from here we can proceed a jump. So after this, we'll check whether this position value reaches at the end of the array or not. It means we can reach the end of the array. So finally, since they are equal, since 13 is greater than the size of the array, which is 10, it means we can reach at the end of the array from this position 4. So we'll return the number of jumps from this particular condition. So in this way, we'll tackle this problem using greedy approach, where the time complexity and the space complexity would be optimized comparing to the dynamic programming way of solving it. So let's code this approach, and we'll say whether it gets accepted or not. So this is the code for the approach we have discussed by using the greedy algorithm. Here I have taken the size of an array, jump variable, position variable, and destination variable. Here the base case would be if the starting element is itself 0, then we'll return -1, as we cannot reach the end of the array. So here I have used a for loop, and I have updated the destination variable, and if at any point the position value is equals to the current index value, we'll update the position value with destination value, and we'll increment a jump. And finally, after the iteration of this whole for loop over the array, we'll check whether this position value is greater than the size of the array. It means we can reach at the end of the array. Here in this case it would be 9, so we'll return the number of jumps, or else if they are not equal, we'll return -1 from here. So let's compile and run this code. So let's submit. As you can see, this problem got solved successfully. So to summarize this, the function efficiently calculates the minimum number of jumps needed to reach at the end of the array. Here we have used a greedy approach, and the time complexity is O of n, making it quite efficient for large arrays. So this is it, guys. I hope you liked my video and my explanation. So please give it a like, share with your friends, and subscribe to my channel for more coding challenges. I'll see you in the next one. Thank you.